Let's work through the solution to the first problem. How many moles of carbon dioxide are produced by the combustion of 4.5 moles of pentane? In order to answer this question, we need the balanced chemical equation for the combustion of pentane that we saw in the previous video. 1 mole of pentane will react with 8 moles of oxygen gas to produce 5 moles of carbon dioxide gas and 6 moles of water. I like to begin each stoichiometry problem by organizing the given information. We're starting with 4.5 moles of pentane. And the question is asking for the moles of carbon dioxide. Remember that the heart of every stoichiometry problem is the mole-to-mole relationship. In this case, we have 1 mole of pentane produces 5 moles of carbon dioxide. These numbers are coming directly from the coefficients in the balanced chemical equation. And remember, this is going to be the heart of our stoichiometry problem. In this problem, we don't have any additional connections to make. Everything is given in terms of moles. So we'll start with our given 4.5 moles of pentane. Use our mole-to-mole conversion factor. We see that the moles of pentane will cancel. The multiplication gives us 22.5 moles of CO2. Since we only have two significant figures, we'll round this to 23 moles of CO2. Let's look at the next question. How many moles of oxygen are needed to form 3.8 moles of carbon dioxide? Again, we have to start with the balanced chemical equation. This time we're given 3.8 moles of CO2 and asked to connect that to moles of oxygen. What's the relationship between oxygen and CO2 in the problem? The balanced chemical equation tells us that 8 moles of oxygen will produce 5 moles of carbon dioxide. Again, starting with the given information, 3.8 moles of CO2, we can use the mole-to-mole relationship to figure out how many moles of oxygen this will be. Once again, the moles of CO2 will cancel out, and when we do the multiplication, we get 6.08 moles of oxygen, or rounding to two significant figures, 6.1 moles of oxygen. Question 3 asks how many grams of liquid water are produced by the combustion of 4.5 moles of pentane. Once again, we need the balanced chemical equation. Starting with 4.5 moles of pentane, how many grams of water will be formed? How do we connect pentane with water? The balanced chemical equation gives us the mole-to-mole relationship. 1 mole of pentane will produce 6 moles of water. In this problem, however, we need to make an additional connection. We need to connect moles of water to grams of water using the molar mass. We know that 1 mole of water weighs 18.02 grams. This is the molar mass from the periodic table. We now have all the pieces we need to solve this problem. Starting with the given 4.5 moles of pentane, we then convert those moles of pentane into moles of water using our mole-to-mole conversion. Remember, this is the heart of our stoichiometry problem. If we had wanted the moles of water, we could stop here, but since we wanted the grams of water, we need to add one more piece. 1 mole of water weighs 18.02 grams. Looking at how all of the units cancel, we see that the moles of pentane will cancel, the moles of water will also cancel, and we'll get our answer in grams of water. Multiplying this out on our calculator, we see we get 486.54 grams of water. We realize that we only get two significant figures, so we'll round this to 490 grams of water.